Hello again. In the next video in this series, we're going to talk about energy from the sun in the use of solar panels. Two types of solar panel. There are solar PV, photovoltaic, and there are thermal. In essence, the sun produces particles of pure energy. These are called photons. When it turns hydrogen into helium, we all know E equals mc squared, so matter and energy are transferable. A little photon shoots out of the sun. It's massless. There is no weight at all. Well, mass. There's no mass at all to a photon. It's a massless particle. Flies through space, hits the surface of the Earth, warms us up. We capture those photons. We use them to shift electrons about. Now, in a photovoltaic panel, there are two layers separated by a layer. A photon hits an electron, it pushes it through the semiconductive layer, goes onto the side. All that does is create what is called potential, electrical potential. Electrical potential is measured in volts, it's just a pressure. We've got too many electrons on one side, they want to come back and form equilibrium. They do that and electricity flows. They run round the wire and they come back, forming electricity. You're taking pure energy from the sun, you are moving electrons, causing pressure differential. So, photovoltaic cells come in many different types. I'm going to talk about monocrystalline, polycrystalline. Monocrystalline, cheap to produce, not quite as efficient. Polycrystalline, a bit more expensive to produce, a lot more efficient. Now, the efficiency of photovoltaic cells in the last few years has gone through the roof. They used to be 12% efficient. Now we're reaching up to 26, 27%. Some of the ones that have been developed for use in space, very expensive, but that technology we are using now and finding cheaper ways to produce them and using that to make them more and more efficient. The other type of solar system, solar cell, is a solar thermal. You will see these on domestic settings more than you will anywhere else. The photovoltaic panels, we can use them on solar farms. I'm sure some people have seen them driving around the country. You'll just see a field covered in photovoltaic cells. They produce electricity on a massive scale. Put them on the roof of your house, domestic setting, again, same principle. Thermal cells have tubes. Inside the tubes, there is a gas or liquid under pressure. This gas or liquid takes those photons, and because they're under pressure, they can heat themselves to extremely high temperatures. They really, really can. That temperature differential is then carried to an exchanger, a heat exchanger. You put water through the heat exchanger, you can actually get it to turn to steam. Obviously in the domestic setting, that's not what we want. It will run your heating. It will alleviate the need to actually burn gas in a boiler. So therefore, if we all use thermal cells, the use of gas as a domestic heating fuel would drop a lot. Now, unfortunately, because we live in the Northern Hemisphere, we don't receive as much energy from the sun as anybody further south. So the further south you get towards the equator, the better it is. But even on dull days, even on overcast days, there are still photons. We know there's still photons coming because we can see there is light. Those photons can still do work. We can still use them to produce electricity. We can still use them to heat up liquids and gases to form a useful energy system for our homes.